So, right, I don't need to introduce myself again, I hope. You can vaguely remember. So I'm going to carry on talking about stuff that's sort of linked into how can we add quality and make sure we're not introducing rubbish into the work that we've been doing, looking at the stuff we looked at prior to lunch, looking at our automated builds, our ARM templates, all of those things. What can we do to manage risk, to reduce technical debt? Is there anything we can do as part of our process that would help there? Well, the first thing, let's step back a bit and sort of, let's look at the security and the threat landscape. So, how many of you at the moment, because I think it seemed that the bulk of the room were devish, more devy than anything else, how many of you actually work specifically in the security sector, if you're allowed to say? So all of you. But how many of you do any formal threat modelling and security checking at the moment, or specifically look at security tools? Some. Not the majority, I think it's fair to say. Not the majority. The whole of this, switch it on and with batteries in makes a big difference. The first thing we need to look at is what's the problem that we're looking at here? We're always constantly seeing things up on the news and everything about security this, security that. But what is a more realistic sort of security landscape? Well, it's been changing over the years. I've been in this business long enough to I sort of came in, not quite at the start of the PC revolution, but pretty soon after. You know, it was IBM PS2s when I started in the mid-80s. New stuff was that. We're not going to play that game. You know, I started on 5-hole, not 8-hole punch paper tape at school. And we used to send away the punch paper tape in 35mm film containers. Remember them, film containers? To North Staffs Polytechnic, where it came back a week later, error on line 10. And my devs complained to me about performance of their dev machines. They don't get a lot of sympathy. Anyway, we had a threat landscape back then. We were seeing boot sector viruses. We were seeing all of those things. They were passed around with floppies. Things weren't that interconnected. There were issues. The stuff started. I don't know how many of you are aware of a gentleman named Troy Hunt. He runs a security blog. Lots of his sessions are up on Pluralsight and on Channel 9 and all sorts of places. And he's got loads of interesting stories around these sort of areas and all of the various stuff. Well worth having a look at sort of the history of some of these. There's also, well, there's all sorts of different resources around in this space. But there's lots of stuff on the early history of those things up in various posts. In the 90s, it moved on. We started to become more interconnected. We were starting to see issues. We started to see issues around escalation of privilege, because back in the day when you just had a Mac or a PC, you probably didn't even log on to it back in the 80s. You switched it on. That was your security. We started to see all of those sorts of areas. There was lots of interconnection starting to appear. And then in the 2000s, we start to hit into the internet. We're starting to be connected. It's where we start to see more attacks being made against the applications as opposed to the network service layers. We're starting to see the social media attacks, the spyware, all of those. The big things there were dodgy macros for Excel, and Word became very big in that era. And now it's more of the same. We're seeing all of the things that have been in the past, but we're now seeing very much things targeted at applications. They're looking at gaining footholds on your machines. There's a lot of debate as to why they're trying to gain footholds onto your machines. A lot of it is, it's probably not that you have enough money in your personal bank account to make it worth the effort, but having the clock cycles of your machine, or the clock cycles of the things you can connect to, is useful to build denial of service attacks against somebody else. With a lot of stuff in the press at the moment is talking about ransomware. We're seeing a big growth in that. People get infected. There have been a number of high-profile cases in the UK of police services, hospitals, schools losing their data to ransomware, and exposing the fact that they don't have particularly good backup strategies. All of these things need considering. That just because we're in the 21st century now doesn't mean we have to ignore all the things that happened before. Some of those are still kicking around. One of the best attacks, if you're going to go into a corporate and you want to get spyware into a corporate, is to put it on a pen drive and throw a few pen drives in the car park outside. I've actually heard it used as a technique that companies have used to see how good their security training is for their staff. They do the security training, then a month or so later, they throw a few pen drives in and then see how many get plugged into the corporate network. The weakest part of the system is the human, and as you notice over on the right, many of those, the spam, the phishing, a lot of the social engineering ones, that's where the issues are coming from. It's the way the people use the systems. So if you as a developer can do something to make them fail in a safer way, you've got to assume that the end users are going to do everything weird that you haven't thought of. And that's really hard to protect against. So we need to be looking at protection in depth. So we have a whole sort of range of different areas of who might be interested. You might want to redraw some of these given current recent political changes across the world as to where you think the right threats are, but it's a slightly older slide here. By volume, if you look at your firewalls, all of your analysis, you're going to see most of the things that are hitting you are script-generated attacks from people who are just doing it because they can. They might be trying to vandalise your site. They might claim they're ethical hackers. There was a Troy Hunt comment I saw in one of his sessions was that an ethical hacker is a hacker who then later tries to justify why they did it. But this area, you can easily download scripts and go in and have a look, and you can go down and download the scripts and try and hack your own sites, a good technique to work out what your vulnerabilities are. The largest area for money off is obviously people trying to steal stuff from you. Ransomware is effectively a blackmail attack against a corporate. There have been a whole series of cases of people coming in and saying, we'll do maybe a denial of service attack using a bot network and go and actually tell the customer or the target, we are going to go and do this attack unless you pay us so much money by Friday in Bitcoin, almost certainly. And if you don't pay, you have a botnet attack to deal with. If you do pay, they'll probably be back next week for a bigger amount of money. And then you've got to justify to your shareholders why you paid off a ransom demand. So it's a troublesome area. The area people spend most money on is governments, and I'm not really going to talk about all of that today. But, you know, GCHQ costs us a fortune trying to protect stuff for the country. But what we're going to talk about is sort of the principles that allow us to mitigate these irrespective of which ones we're looking at. And the final one is, this is a growing area. We are seeing more and more stories about ransomware, denial of service attacks, all of these various different things. So that's the sort of the area. So what can we do? What can we do to try and protect? Well, the historic answer has been, you put in a firewall and then you're sorted. Yeah, that's historically the IT pro corporate. I've spent a fortune with name firewall company, will be fine. That won't fail. And maybe even you get, and try and be clever, and I'll hire somebody to do some penetration tests. Yeah, and the penetration tests show you've got a good firewall or a bad firewall. But that's all it's doing. You're only protecting the boundary, and that's its bigger problem. Firewalls are a really big part of the solution, but they're not the whole solution. It's really important. You've got to think of everything together. We have to think about defence in depth when we're doing this type of work to make sure that we don't make the assumption that once they've hopped over the wall, they can do absolutely anything. Why do you trust somebody working at a PC in your accounts department any more than you trust somebody who is sitting in working remotely when they're sitting in a cyber cafe in Beijing? Should you? What's the choice? And so you often start to see, well, maybe firewalling the perimeter isn't enough. Maybe you firewall between departments, between apps. And we stop using the hardware firewall and we start thinking about segmenting services and that sort of things. It's not even firewalls logically, but logical segmentation starts to become really important. And a really important one there, which touches back to what I was talking before lunch, if devs do something and don't tell the IT pros, they can't put a firewall around it. And how many places have we worked where you get the, I'm just going to use the firewall bypass protocol, port 80. You know, because I can't be dealing with all of this, it's too hard. So, you know, if you start spinning up everything on port 80, you know, there's not a lot they can do with traditional firewalls. You can do it with sort of clever level 3 stuff, but it's still a bit of an issue. Because the problem is the software, is what it boils down to. You know, hackers don't create the holes, they exploit them. They find the mistakes we've made. So what we need to do is mitigate and put as much in our dev process so that we can easily stop adding the holes, plug the holes before they happen, and also know enough about our own systems to say, to tell the IT pros what they should be protecting with the traditional types of security. There's a few more. It's all basically the same. It's the attacks have moved, they're moving down the layers, they're not trying to hit things straight, they're looking inside your apps, they're looking for vulnerabilities in your apps, they're not trying to hit Windows or Linux per se, they're looking for the app that's running on top, because that's probably where you've exposed a vulnerability. I'm sure you've seen graphs like this related to requests for change and bugs and everything. If you can spot the issue earlier in your development life cycle, it is better. It is vastly cheaper. Also, when it comes to security, there's a chance that a security issue will have far more impact on your organisation's reputation than most other types of bug, especially if you're in a regulated sector. And when I say regulated, I mean something like you take credit card payments and you've had to be PCI audited. You know, a nice big security vulnerability is a great way to rip up your own PCI certification quite quickly. So it's one of these things you do need to protect against. And it's worth looping back on here. If I don't know how many of you work in sectors where your work is PCI audited, or yeah, there's certainly some in the room. You need to be able to show that you are trying to mitigate these risks as part of your PCI work. So the type of stuff I'll be talking about as we go forward is stuff that can really make it easier for you to get your PCI certification, because you're showing a reliable process that mitigates these risks. But that said, you could spend an infinite amount of money on security and an infinite amount of money on actually trying to deliver stuff. There reaches a point where you have to decide what is a reasonable cost. Because the attackers, their tooling always gets cheaper. There's another library out there. They can buy a library, find a library. If they need massive volume to do something, there's this thing called the cloud. It's really good. You can just, if you've got a big enough credit card, you can run yourself a lovely big botnet attack on legit services. Now, the cloud service providers sort of look at your output and sort of block that, because that's not a good thing, but it's relatively straightforward to get access to botnets, which can give you huge volume. So it's getting harder. So there is a point where you have to make a business case, risk choice about how much work you're going to do, how much money you're going to invest in one of these processes. But why is our software bad? Well, there's a number of reasons. I don't know how many of these chime with yourselves. You know, it's something that gets in the way of doing the software easily. It's difficult. How do we test it? You know, it's not what we do. You know, our devs don't have security skills. We have specialists for that. So we write some garbage, then somebody looks at it and tries to fix it later. Is that really what you want? And time spent on security isn't time writing new features. And we've all worked at organisations where technical debt grows because a new feature is more important than making what you already have reliable. And security is another area that we need to consider in there. But the point is, we have plenty of technologies and tools now. It's not like we're missing some super magic bullet. Now, I'm sure the people working down at MSR doing all sorts of wonderful machine learning stuff about security to find holes and plug holes and do whatever. But we don't need that to do a fundamentally quite good job now. We need to use the tools that we have already, and we need to use them consistently. And one of the things that's talked about in Agile project management is that we talk about having retrospectives. So at the end of a sprint, you look back at what you did and you ask yourself the questions, what worked, what didn't work, what should we try again? And you need to follow through on that. This is really true of security. You need to think, we found a vulnerability, we could do this to fix it, and the hard bit, and actually do it going forward. And the reason so much of this fails is because we just don't bother to do it. We could, but we don't. So, life's easier for the attacker. They only have to find one vulnerability. As a defender, we've got to check and defend for loads of things. We're probably, as defenders, time constrained. We've got budgets, we've got to do stuff. The attackers, if they want to, can play forever and pull on, frankly, infinite resource. We can lock down a system to make it impossible to use if we want to. But then you're removing business value. There's always a balancing act. It's hard. So we need to make things simple. And we don't want to impact business value. So those two are quite tied together, but we don't want to do security as a last minute thing at the end. It's like you don't test at the end. You can't test quality into a product. You engineer quality into a product. You can't test security into a product. It's exactly the same. So, the title of this was looking at sort of the big ones, the ones that still bite us. I don't know how many of you have read the 24 Deadly Sins. It's not a relatively readable book. There's also the title of this, so we're talking about the OWASP top 10, I'll come back to that, which if that just sort of lists over the past umpteen years as to what have been the biggest security things seen in the wild. The lists are very similar, and they all talk and give background. So I'm not going to deal with all of these, but I'm going to talk about some of them as sort of that are nice and relevant to our industry. So the first one is, the first security sin, which isn't really a sin, but it's that, it won't happen to me. We're fine. It'll be good. My language is perfectly safe. We've all heard that one. And that's one you really do have to be careful of. Pretty much every language will have some vulnerabilities. And you need to remember that. So not actually sort of a proper sin, it's sort of like a precursor sin, the act of denial, the act that you're safe. Still one of the biggest, and when you start to look at all the things that have hit the internet of late that have been dev-focused, like the Heartbleed one, and there's, what was the one a couple of weeks ago? I can't remember what it was called. There was another one kicking around, and they were all in low-level shared libraries written in C, and they were down to simple buffer overruns. So a buffer overrun, somebody does something in the code, and you get access to a bit of memory that you're not meant to have. And with a bit of fiddling around and playing around, you can elevate rights, do all sorts of things. It varies depending on the platform that you're working on. But fundamentally, you're not checking that you've allocated memory correctly, and you walk off the end of an array and get into a place you're not meant to. Many people seem to think that these things can only affect C++ languages. That's not true. They're different in managed languages because the memory is managed differently, but you can still hit problems. Now, the common one I'm aware of is if you're a C# programmer and you link and you dynamically encode, programmatically link an event, say, to a button on a form, and then dispose of the form without undoing the programmatic link, you end up pinning that in memory, and that can cause buffer overruns. So it is possible in C# issues, and I believe Java has similar issues. Weirder edge cases, they're harder to do, but they do exist. Now, that said, you are still most likely to see them in C++, and especially in those big open source libraries that appear everywhere. Standard things, you know, they can be a real problem. So as I say, the common myths, they only affect Microsoft platforms? No, they don't. They can affect anything. They are possible in managed languages. They're just a bit weirder to get to. They're not just straight blatting in dodgy data. It normally requires some program construct. And the last one, before, can it be exploited in applications? Well, they can. That's a bit beyond my knowledge of exactly how you do that, but they are common issues. Probably one of the commonest, and it's scarily when you look at the results of what's been published as being common security issues. The SQL injection attack is still really popular, still staying up there in the top 1, 2 or 3. And you would have thought we would have learned our lesson by now. It's a really old one. The problem that you have is that when you dynamically build some SQL query, and it doesn't matter whether it's Microsoft, MySQL, Oracle, you can do it in all of them. You dynamically build some SQL, so you read in some text somehow, and you append it to the end of your SQL string, which has issues of its own there, frankly. And so if we put in our box, instead of typing in 105, we've typed in 105 or 1 equals 1, that's going to return every row. So that SQL injection attack will return every user in the database, not one. But by clever use of comments and things like that, you could put in any SQL command you want. And SQL has the interesting thing, it's one of the few languages which is a data definition language and a data manipulation language. So valid SQL, as well as returning data, which might be a really bad thing, can also allow you to update your database schema. So if you get a drop users, you can, if you've got your security privileges, remember we're talking about layered security, you can end up with getting all of your data deleted as well. So there's a huge vulnerability, and that was the one that took out TalkTalk. Was it about 2 years ago? That was, I believe, PHP, might not have been PHP, but it was effectively a website that was open to a SQL injection attack, was the analysis that came out in the end. And you'd think that wouldn't be happening these days, but it still does. Sometimes in legacy code, scarily sometimes in brand new code. So what do we do about that? The thing we want to do is to prevent it. Now, you can make use of stored procs, but the simplest one, if you're working in C#, is to always call commands with parameters, whether they be stored procs or whatever. So we parameterize out I parameterize out these values here. So I don't build the string with string concatenation. I pass it through something that knows how to parse SQL. So it doesn't. These don't allow in invalid SQL commands. And that's a common trend in all of this security stuff, to keep it tight. Validate your input. Do not trust what anybody has typed in. Always check it. And if the language, the tooling gives you stuff to do that, that really helps. That really helps you lock it down more. Step too far away. No, you've died. So, the other big one is cross-site scripting attacks for the web. So, the key there is someone is injecting something into the client-side code. Now, a few years ago, people were talking about, my corporate that I work for, we have JavaScript switched off. You're not allowed to run JavaScript inside our organisation. I'm not convinced that's a viable strategy anymore for most web usage. So JavaScript is going to be there. It's something you need to defend against. And the cross-site scripting attack is one of the primary ways in there that you should be protecting against it. So what is a cross-site scripting attack? There's a couple of examples, and these are often linked in with the sort of the phishing style attack. Somebody sends in an email which has a link that you need to follow. That link contains some embedded JavaScript. As we all know, you never click a link in an email. You always open it, put it in Notepad, have a look at it first before you're going to do it, or just ignore it. Then that gets pushed up to the server, and if there is a cross-site scripting vulnerability, so you're taking that ID input and reflecting it straight back in the browser, that can just be executed inside that machine for that user. So now the malicious code gets run and it does whatever. And that's the entry point in for many ransomware type attacks, all of those sorts of things. So the key there is, the protection is you make sure you validate to make sure that embedded JavaScript can't be passed in as a parameter. But you as the dev need to remember to do that. Now, there are frameworks that help on all platforms to ease that, to make life a little easier, but it is still something you've got to consider. The other one is a slight turn on that one, which you use basically the same method. Somebody injects some code into a server and it gets persisted to a database. So when everybody else retrieves it, they get yeah, back one. There we are. It gets passed out to everybody, so they can persist, they might not. There's all sorts of different things around there. But again, something we commonly need to protect against. And again, we get those cross-site scripting only affects Microsoft. Nope, it can affect anything. And cross-site scripting, this is the scary one, can be protected as long as you use SSL or transport layer security. And this is not an uncommon theme across the board, that the thought is that something an IT pro can do can protect against your dodgy dev practices. It can't. They can do a lot, but they can't protect against everything. And unfortunately, things like SSL can often make things harder because you can't do inspection on the way. You know, certs can often sometimes hide issues. Another area that can be a problem is information leakage. So it's always a difficult one. We certainly don't want to give out more information than we need to on a website. You know, and it's always, I was showing before the break, I like to put a version number on the website so I can see which build's gone out. But is that a good thing? Discuss. It's good for a demo, but is it good in production? Because if there's a known vulnerability because you're using such and such a version of a DLL, do you want to advertise that fact? I think the fact here is that an awful lot of the information leakage will come from people running scanners, port scanners, and a variety of other scanning tools that are available to the hacker community. There was a chap called Niall Merrigan. I don't know how many of you know him. There's another MVP recently did a press release. They'd found a vulnerability in, I think it was MongoDB. It was a couple of 3 weeks ago, and it was a ransomware issue. And it's not a fault in MongoDB, but it's a fault in the default settings of MongoDB. So if you do a default install of MongoDB, it leaves itself unsecure. And you need to change a config file to a safer default. And they'd found this vulnerability. And people are writing port scanners to go out and find all the MongoDBs that are thus exposed. So it's one of those, it's an interesting one. Information leakage is a problem. You should do everything you can to avoid it. But sometimes you do need to pass information out. Otherwise your service doesn't work. So it can be an awkward one, that one. So we've talked about some of the big sins. I don't know why I'm holding that. Battery's gone. What can we do? So this is getting to the devy bit. What can we do as devs or testers or IT pros? And I mention all three because I'm going to talk about some of these things. You want to do this as a group because a dev or a business analyst will probably only think about the happy path. I want to make a system do this. Well, hey, it does it. If you've got a good tester, well, the IT pro is going to think about what are my security vulnerabilities? Am I opening the right ports on the server? Fundamentally a happy path with a bit of lockdown on it. And hopefully, if you've got a good tester, they're being evil. And they're going, oh, how can I break it? Which is a good entry point into all of this stuff. But what we need to consider are the threats. What might somebody attempt to do? The vulnerabilities, the holes we've written in our system, and the exploits, which is somebody trying to use a vulnerability. And threats and vulnerabilities aren't the same. There's a different tone. You know, the threat is what someone might do to get into your system. The vulnerability is how they might do it. We need to consider both. So, one of the most important steps you can do as a dev team is threat modelling. So you need to take your system and have a think to see what the threats are for it. What can be done to your system? So The way we would normally recommend you do that is looking at doing a threat model. And we talk about, to try and identify the different types of threats on our system, we use the STRIDE model. So we talk about the various different threats. So the first threat is spoofing, pretending to be somebody else. Tampering, can I modify code or data while it's in flight? Or while it's stored, for that matter. Repudiation, can I do something and then claim I didn't? Give me £1 million. I never asked for £1 million. You know, what can I do about that? Information disclosure, finding information people shouldn't be allowed to use. Denial of service, not a lot of dev can do there. That is a more IT pro one. You need to protect those things normally at firewalls. And elevation of privilege. Do users have the appropriate rights to do what they're trying to do? So once you've got those, what you would normally do is, we've got some arbitrary little system here. It doesn't really matter what it does. We've got a user who comes in and does stuff. We can model that. You know, this happens to have used some data flow diagrams, but that's not important. The key point is we look at that system, and at every point in it, we look to see which of those threats are applicable to it. Now, it could be a threat is available in multiple places. You know, here, we could pretend to be a different user. The user could send commands, but we could intercept them on the wire and transpose them. Repudiation, we could send a command, then denied we send a command, and it goes on and on and on. You need to identify those various different types of issue that you may have. And then you can start to prioritise them. And here we use the DREAD model. So it's STRIDE and DREAD. So with STRIDE, if someone exploited this, how bad would it be? Because we know we've got limited resource to fix these problems or address these problems, or mitigate at least. So we need to prioritise. So what we can do is we can say, how much damage would happen if somebody did this? Is it possible to do it? And how hard is it? You know, are we talking Mission Impossible, dangling from a rope, not sweating, dripping on the floor, while somebody holds you on a rope while there's a rat nibbling him? That's quite hard to exploit. But if it's a case of I can exploit it by dropping a pen drive in the company car park, and we know they love picking up pen drives here, you've got a far easier exploit. How many would it be affected? And interestingly, how likely is it that somebody's going to find this weird and wonderful exploit? Remember, security by obscurity is not security. You know, just because it's hard to find, secrets escape. That is their nature. So what you normally do is give that a scale of 1 to 5 or something, and you can create a mathematical model. So you want to walk through, look at all of the threats that you've done, identify a threat, and give it a DREAD rating, and that will give you a feel for which ones you should be prioritising first, which ones are the most likely. So you've got a nice long list, and they should be going onto your backlog of work like any other piece of work. You know, something you should be doing. So perform regular threat models. Use a consistent process. Maybe it's part of your sprint planning. Maybe you go, well, we don't need to do it every sprint. We do 2-week sprints. That's too much. We're going to do this quarterly. Whatever. Come up with a process, document it, make sure you know what it is, make sure everybody throws it. Make sure that if you're raising bugs, they are identified that they are security related, so they are given the proper prioritisation, and prioritise them as risks to your business. Your non-technical or your non-IT technical business staff understand risk. Risk is big in business. They'll find it far easier to relate to issues of risk and return on investment than they will on arbitrary discussions about cross-site scripting attacks. So, what sort of mitigations can we put in place? Well, the first one is you rewrite your system. That's always good. Start from the ground up. And if you're in a greenfield site, that's good. Try and start and put in good practices to mitigate those risks. You know, we talked about with the SQL injection. Well, don't write it like that. But realistically, most of us don't work on greenfield systems most of the time. So what we need to do is come up with a different way of doing it. So we have some standard mitigations. You could use the standard mitigations are better than using unique ones. Always try and standardise, use the same things. But interestingly, just accept the risk is sometimes the right answer. this is so hard to exploit and so weird an edge case, we're going to take the risk, or we're willing to take the risk for version 2, but we'll fix it in version 3. If you've got the information and the metrics, you can make a valid business choice. So, a few examples, you know, to avoid spoofing issues, use digital signatures. To avoid tampering, message authentication codes, digital signatures again. Repudiation, you can often address by logging that someone has actually seen it. There's standard ways of doing all of these things. And if you start to look through the Microsoft Patterns and Practices website, I don't know how many of you have ever used that. Just search for patterns and practices at Microsoft. They have a whole pile of standard templates and standard ways of structuring certain bits of code to mitigate this type of thing, so standard procedures to try and get around them. And a really common one on that is to reduce the surface area. So one of the common, the MongoDB one was an issue because it was, by default, it was connecting the database to every available network adapter. If you only connect it so it can only be talked to by the machine it's on or a specific IP address, you've reduced the area for attack. Windows made a huge change in this area from Windows 2000 through its various versions of picking safer defaults. It used to be, back in the Windows NT days and 2000, you installed Windows and everything was switched on because you might want it. Now pretty much everything's switched off and you have to enable it. Reducing the attack surface makes life a lot easier. The next one is sort of defense in depth. Don't assume this is your firewall. Don't assume that one level will fix everything. You want to be checking at every level. So if you're using a microservice architecture with lots of little subunits, don't assume that it made it onto your message bus, that it must be cool and good. All it takes is one of the things to fail and you've got that same problem. You know, why do you trust all the PCs in your organisation? You should be worrying about individuals. So you need to check at every single level and make sure you run with the least privilege. You can deal with, if you only need to retrieve data from a database, you can at least by making the user read-only or not giving them rights to update the database schema, reduce the worst excesses of a ransomware or a delete everything style attack. The worst they can do is steal your data. Still bad, but it's not as bad as deleting all of it. And I've already touched on this one. Have secure defaults. Make sure everything's defaults nice and safe. A lot of the things I've mentioned going along have been down to problems with people typing nasty things into text boxes and then injecting them, or typing them on command lines and passing them through. Never trust anything a user types. It's a really good adage here. All input is evil. And so always make sure you pass everything through trusted parsers. So if you're worried about cross-site scripting attacks, which you should, and you're taking free text entry, make sure that the data in that text box is passed through to make sure that it is not stored as JavaScript so it can be run. That's standard stuff in pretty much all languages now. You need to make use of those. And so you need to validate length, type, range, whatever's appropriate, but you should be able to find standard defences for doing most of those things. And in some cases, you also get the option that the compiler has defences in there. Now, some of those are warnings and things like that, but you can actually, particularly in the C++ area, there are a whole pile of flags you can put in that look for standard sort of things that you shouldn't be doing. And that's closely linked to banned APIs. Again, this is more, from my experience, a C++ one, but there are lists of API calls you shouldn't make because they're now deemed to be poor. And there is actually a link down here on that one for the last list that Microsoft had. But you do actually see it's being used in a wider area, and that is where you're looking at things like security APIs, encryption, hashing. Now, the recommendation from Microsoft at present is you don't use MD4, 5, RC4, DES or SHA-1. But I know I was talking to a client recently who was saying, oh, we have to use SHA-1 because the system we're connecting to further down the phone, that's all they'll use, they won't use anything any newer. And you're going, but that was breached a scary number of years ago. So how secure is that going to be? So you're always going to have these discussions, but at least you're in a position to have the discussion as to why you should be sticking on using something reasonably up to date. So, we've talked a lot about how and all of those things. How does all this wire in? And what can you do about testing? So there's a very quick one, because I know the final session of the day is going to be talking about how you test the thing that you've produced and how you make sure that it is secure and nice and safe. But in essence, the big blue thing you knew, the big blue circle, you knew what you intended to write. So you could write tests for that. You only shipped part of it. So that's the bit you probably actually test. But heaven knows what all the stuff you never thought about did. And that's the area you're probably never going to write tests for those, the actual functionality, the weird bits around the edge. So that starts to move into the security testing, the pen tests, and all of those various different things. Finding security bugs is different to testing known functionality. You need to start to look around the edges. It's a different art. And it is an area that you may want to consider using specialists in those areas. But keep thinking around there, well, so-and-so wouldn't do that. Remember, people will always try and come in around the edge. They'll try and use exploits that you have incorporated into your code. Not maliciously, you didn't write the vulnerability, you just didn't mitigate against it. And that's the type of thing we're trying to protect against. And penetration testing particularly can be useful for that, and there are tool chains for doing all those sorts of areas. But the one, because this is more dev focused, the area that's more interesting is what can you do internally? And a really useful one is, how many of you do code review? Not bad, it's third of the room. Every time? Yeah, that's the one. Having a second pair of eyes on a piece of code is a really good idea. You could do that with pair programming. Two of you sit together and type. Every line is code reviewed. Not that many people do that. But you certainly see things where when people check in code, before it's allowed to be merged into the main branch, it has to go through a code review. TFS has offered that for years. This has been a code review feature. Since it gained Git support back in 2013, was it? We've seen the advent of the pull request coming into VSTS and TFS, and that's a really nice way of doing a code review using the Microsoft platforms. And there, when somebody wants to do a merge from one branch to the other, you can set a branch policy that says nobody is allowed to check in code onto the master branch. Well, no one's allowed to commit. We're in Git land, aren't we? So it's commit. That what they have to do is ask for a pull request from a working branch. Now that might be a branch that's shared by everybody and used for a sprint, or one that's only got their new feature on it. They pull that code in. They actually ask whoever owns the master branch, please pull my code in, and you get this to do a pull request. So we can have a conversation about your code, we can go in, we can look at the code that's in there, we can wire in the automated build that we saw before lunch. So yes, I know it builds and all the automated tests pass. Yes, it's associated with a work item. I can now come in and approve it. Or if I don't, I can have a conversation. I can ask you to modify the code. That can be a really good protection for you to make sure that the stuff that you're doing works and meets your current security guidelines. A second pair of eyes. Next one's release management. We saw that before. Often vulnerabilities are introduced due to human error. Somebody forgot to copy something. I don't know, did you ever see about a couple of weeks ago where GitLab went down? I don't know how many of you are aware of GitLab. It's another source control system in the cloud. That went down because of a typo. Somebody made a typo whilst doing routine maintenance, and it caused some data loss that took them 6 hours to recover from. If you automate these things, people make less typos. Now you can make the argument, well, he was running a command line script. Well, maybe it would have been better if a robot was running a command line script. You know, an automated timer process, because at least it's run the same every time. And this comes back to what I was saying before the break. That sort of, you've got great automation till you get to production and then you do it differently. Is that the right move? And those are the type of things you need to consider here. that you need to think about doing good automation, and when problems do occur, you already have a response plan in place. You don't want to be reacting. You know, firemen don't run around going, how do we put out fires when they arrive? They've practiced. The same thing holds true of security. Think what your process is. Keep a release archive, keep a way of moving forward. And when you do have an incident, think about it and document it and do a retrospective of the security incident. Why did that happen? Why didn't our threat modelling fix it up? Should we do our threat modelling differently? Should we do our threat modelling? Should we do our threat modelling and actually do something about the stuff we've decided as opposed to just ignoring it? That last one is quite common, I find. They do all the modelling and then you don't actually continue. As I say, that's too often forgotten. So, I've done a lot about what's around the edge, the theories behind, the common problems, that we're still seeing the same common security problems in our industry that we've seen for years. What can we do about it inside TFS or VSTS? So, is there a special security template inside TFS? No, there isn't. There used to be. Back in the, I think it was 2008 days, Microsoft did have a secure development lifecycle process template you could download and install. Hasn't been maintained in years. You need to grow your own, frankly, because your process is your process. Now, it has a few things that were used to be in that one that were quite interesting, and there were things that it should really have in it. So, the first one is, a lot of audit processes talk about, if you do have a security incident, have a way of flagging it was a security incident and not something else. You can do that in TFS, VSTS. Put an extra field on the work item. Use a tag. That works great. Nice and easy. Do your code reviews. Well, we've just seen. You can do a code review in TFVC and you can do a pull request in Git. That gives you a nice mechanism for code reviews. That's good. And look at using static analysis. So that means extend your build process to run any tools that are available to you to mitigate these issues. So there's all sorts that we might talk about using there. So first one is unit testing. Unit testing gives you a measure of security and code quality. Maybe not the most relevant for a security discussion, but it's certainly part of the story. The next one is use code analysis, which for those older in the room used to be called FXCOP and used to be a separate plugin for for Visual Studio. It's now baked in. It's the code analysis option, the code analysis tab that pops up when you do a compile. You all aware of that one? Yeah. And those are all the CA warnings that you get when you build your application. So that can be a really useful thing. That picks up a lot of cross-site scripting issues. A lot of the cross-site scripting rules are wired into that. So that will show you if you're doing bad practices. There's also static analysis for SQL queries based in Visual Studio. So if you're using SQL Server database tools, that has analysis in there that will look for that type of stuff. We always had the thing called StyleCop, which is still available, which is an add-in for Visual Studio that looks for other areas. It's less security, it's more style related. So in the way Giles was talking about that editor's config, it's sort of being replaced by that. But it still might be an option, it still might do stuff that helps. So coding conventions and styles help consistency of code, consistency of readability, help to mitigate these issues, makes your code review items easier. The final one on that list is arguably the most interesting, and that is a thing called SonarLint. Now, I'll be talking about SonarQube in a moment, but SonarLint allows you to run the same rules that SonarQube would run, but inside Visual Studio, and it keeps the rules in sync. So think of SonarLint as a replacement for the code analysis and the StyleCop all sort of being rolled into one, nice and neat. So that's not like a nice way of working with it. So your first layer is stuff you as a dev can run on your machine. But then what we want to do is also wire that into our build process. So inside our build process, have continuous integration. Make sure your product builds every time. Use code reviews to manage branches in. Use gated check-ins in TFS, and in your continuous integration builds, run all of those tools that check to make sure your devs are sticking within your guidelines, and fail the builds if they're not. You know, if someone has written a detectable cross-site scripting attack, vector, break the build, and they have to fix it. And it raises a security bug in TFS or VSTS or whatever your source control system is. All these things are possible whether you're using TFS, VSTS or any other tools. It's just a case of getting the script running, making it part of your process. But Microsoft have made life easier by adopting the use of SonarQube. Now, do any of you use SonarQube? Couple? So, a few more on this side. So SonarQube came from the open source Java sort of community. It's actually a Java application. And what SonarQube does is it allows the roll-up of results from many different analysis tools. It doesn't actually do analysis itself. It has a runner that triggers something else. So it could trigger StyleCop, it could trigger FXCop, it could trigger NCrunch, whatever tools you want to wire in. So what you can do is you can wire that into your automated build process. So what we say is we go in, we do our automated build, and as part of that automated build, we do all of this static analysis. And this static analysis is tracked and stored on the SonarQube server. So every time you build your product, we're taking this analysis. Now, you do have the option of failing the build because you've broken some rules, but you might not want to do that. I'm sure one or two of you have some older code bases that are quite horrible, and if you ran them through static analysis, it would find many, many faults, but you don't have the budget or the time or maybe the ability, given the constraints you're under, to actually fix them. But it'd be really good to know that you're not introducing more problems. SonarQube allows you to do that. So what you can do is you wire it in and you end up with a dashboard like this. So I'm doing analysis of some projects there, and it's giving me measures of reliability, security, maintainability. That's all based upon it's run a whole pile of rules. They might be StyleCop rules. If I'm on C# project, there's StyleCop rules, FXCop rules, Roslyn rules, whatever. If I was doing a Java project, there'd be different rules. If I was running a PHP project, there'd be different rules. If my project was half Java, half C#, it'd be quite a weird project. But I could run the appropriate rule sets and it would map them over the top. And what we can see is all of the rules are marked down as whether they're reliability, security, maintainability. See, I've not got much code coverage stuff running here. It's also looking for code duplications. It's also detecting the languages that we're using, so it's giving me a clue as to the rules. And what I can do is, it's giving me a rating currently for how good that app is. And I can actually apply what's called a quality gate over on the right. And so I obviously have a quality gate on here that says that collection of values we see here isn't good enough, so I'm getting a warning. I could have a quality gate that says this passes. Maybe they've all got to be A's for it to pass. And if there's anything that's amber, it goes to warning. You control all of this because behind the scenes you've got 1,000-odd rules which you've grouped up and said, run these rules against this code base, and then judge the results and say whether it meets the quality gate or not. So you can actually say, fail my VSTS build if StyleCop isn't happy that you've met a given quality gate. And what is particularly nice is it tracks it over time. So we can actually see for a given bit of code how over time, so bugs and vulnerabilities, duplications, code smells. Code smells are like minor things you probably should fix, but they're not super critical. You can see how many you've got, and it talks about the leak period, i.e. the code you're working on at the moment. So you could set a quality gate, says, I know that my old system was C's across the board in whatever you're measuring. The next release must be at least C's, preferably A's or B's. But if I get a D, I need to fail that. And you've got lots of granularity of control in here for SonarQube to surface this up. So it's a big area, and you can apply this SonarQube to pretty much any language, and I'd really stress having a look at it. Now, an interesting one, you can install it yourself on a VM. It's free, SonarQube. Some of the language interpreters cost money, but Java, C#, JavaScript, they don't. C++ and C does. So that's one that to be aware of. But there is an ALM Rangers. I don't know how many of you are aware of the ALM Rangers. They're people like myself, consultants in TFS, VSTS. Some of them work for Microsoft, some are externals. And we try and write best practice guidance. And I know the ALM Rangers have just released an ARM template that builds you a SonarQube server. It's almost like this is tied together with a unified story. So if you just search for ALM Rangers and SonarQube, you'll find an ARM template that you can run in Azure, and it will build you a SonarQube server with a few clicks. And we can wire that into our build process with a couple of steps. Now, I'm conscious of where the time is. I've just got one more slide I really want to mention. And that is, if you've got a process and you're checking it, and this is a really good one if you're doing PCI compliance or equivalent, and that is, have a sample of code that's awful. So you can prove your process works. Because there's no point putting all of this stuff in place and it doesn't actually detect anything. So have a dodgy version of code. Now, you may have a dodgy version of code to hand already. But if you don't, I'd strongly recommend you go to the OWASP site, where you can read a lot more about these. And they have this site called WebGoat, which is a bad bank. It's a bank that's got every security vulnerability you've ever seen. And they do a .NET version, and they do a Java version, and they do a PHP version, and all sorts of different ones. And it's really useful. A technique we do is we stick that in a Git repo or in TFVC somewhere, and we have an automated build that goes off and builds the bad bank and runs it through our security release pipeline. And we expect it to find all of these errors. And if it doesn't find those, it shows that our release process is a bit useless. And it's not doing the security stuff. So you need to prove your process is broken. That can pick up broken processes. And that's really important. And that's well worth having a look at. And if you are interested in this area, the OWASP site is a really good entry point to discuss around all of these things. So, in sort of summary, don't wait till you're in production. It's too late. You engineer this sort of stuff in. You don't do it later. It needs to be considered repeatedly during your process. You need to threat model regularly. You don't have to fix the things the threat model shows, but they should be affecting your backlog, your priority of work. And if you put it in the right language, it will be understood by your business. And education is important. It's really important to get all your devs au fait with these things. And maybe that just means watching a Channel 9 video every month or two. Just search for security and watch a Troy Hunt or an American video or whatever. Read up on the subject. It's awareness. And when you're onboarding new staff, point out these common problems. And don't rely on the fact that sample sites that you download your standard, hitting a website, hitting SQL, website, that it won't have these bad practices in there. There's an awful lot out there. And and security is always changing, so you need to keep on top of it and keep reading around. But in many ways, the fundamentals are the same. They left a port open, it had stupid defaults, it was running as admin. They're common threads, and they're not going away very fast. So again, a few more useful links there. Some have done that once, so track changes. Useful books to read. And what I will do, a couple of people asked me, I'll make sure these slides are up on my GitHub repo tonight. So if you don't manage to take photos, and if you've got any questions, unfortunately I have to shoot away after this. I can take a few quick ones outside if desperate, but we have another speaker who's waiting to come and plug in and take over, I assume.
Absolutely, thanks Richard, thanks for that. Yeah, we're just hooking up Xamarin now, so we'll be here very shortly. So Mike James will be kicking off on the Xamarin in just a second. Yep. Thank you.
Okay.